Oh, hello. I didn't see you there. I'm Michael Quigley, and we're the Foosfools. So the idea behind our project is to take the goalie position of a foosball table, to attach motors to it, to run object tracking software to track the ball, so that the goalie can properly deflect the ball. We're trying to do this quickly, and we're trying to do this on an embedded system. The embedded system of choice consists of a bugle bone, MSP 430s, and motor drivers. So this is our setup right now. It is the bugle bone, MSP 430s, the motor drivers, and the motors. The motors are pretty high torque. They're about 125 ounce inch. One of the motors will be attached to the rod to provide rotational motion so that it can move back and forth. Another motor will be attached this way to provide translational motion to the rod so that it can move this way. Now we have a webcam up here. This is attached to the bugle bone through USB. The bugle bone is running OpenCV, so it is responsible for all of the object tracking. So what we do is we initialize the table. We identify where the table is in reference to the ball and in reference to the camera. So that's the first thing we do, is we initialize the table. Second, we initialize the ball to figure out where that is in reference to the goalie, in reference to the middle of the table. There are several other parameters that we need to figure out how to properly deflect the ball from the goalie. This is the output of table initialization. We find the center circle and we average out the size of that, and then we find the average angle of the rods, and from that we can find useful table parameters. This is a quick demonstration of our software running on a laptop. We decided to run this specific example on a laptop as opposed to the motor example, which was being run on the bugle bone, because in this example it's easier for us to demonstrate the actual prediction and trajectory of the ball. The prediction of the ball is the red dot, which is covering up the ball in this example, and the green line is drawing the prediction of the trajectory. So just as a simple proof of concept, we have a ball here and we have two motors there. Now the two motors are connected to the motor drivers, which are connected to the MSP 430, which is connected to the bugle bone. Now I'm going to demonstrate the motors moving based on how the ball moves. So one of the motors represents the motion of the y coordinate, and one motor represents the x coordinate. So let's see what happens. So this is the y coordinate, and there's the motor. So as you can see, when I move it one way, the y coordinate moves one way. When I move it the other way, the y coordinate switches direction. Now that's for translational motion. Now for the rotational motion, I will rotate the rod, and as you can see, the x coordinate motor moves. And so right now since we don't actually have the motors connected, we found it a little bit easier to just show how the whole system can respond to the ball's motion, as opposed to just predicting the trajectory of the ball and moving the motors with respect to the trajectory. Because since we can demonstrate that we can predict the trajectory, and we can also demonstrate that we can move the motors with respect to the ball, in theory it should all work. We just need to connect the motors.